So in example 4 here, they want you to find the present value of $40,000 due in 4 years at an annual percentage rate of 4% compounded quarterly. So basically what you're trying to do is figure out how much money you'd have to invest now at this, so that in 4 years at a percentage rate of 4% compounded quarterly, you'll have a total of $40,000. So, so they have this formula here, P equals A plus 1 plus I to the negative n power, where again, I and n are defined as they were in the compound interest formula. I is basically R over M, R being the interest rate, M being the number of conversion periods, N is equal to M times T. So what they would have you do is calculate the principal by plugging in 40,000 times 1 plus 0.04 over 4, all raised to the negative 4 times 4 power. And if you work that out, you get that the principal needed was $34,112.85. So using the formula, it's pretty cut and dry. But again, that's another formula you have to memorize. This formula is really not needed because all you're really doing with this formula, and all this formula that you're seeing in front of you really is me taking that compound interest formula, and instead of having it solved for A, it's being solved for P. That's really the only difference. So if I take that same compound interest formula, and I just put things where they belong, I know that the final amount, the amount I want to have, the accumulated amount is 40,000. I know I'm looking for P. I know that, R is 0.04, N is 4, in the way we're defining it here. N being the number of conversion periods, and T being the number of years. When I take that 1 plus 0.04 over 4 to the 4 times 4 power, I get about 1.17257865, and I would use my calculator's memory features to help me with this, typically, because actually your calculator does store more decimal places than it even shows you on the screen. And if I divide both sides by that 1.17, so forth and so on, it ends up being $34,112.85. So there really is no particular reason to memorize another formula. If you have the formula for compound interest, compounded, other than continuously, which is a slightly different formula, memorized, you don't need the present value formula. You don't need the effective rate formula. All you have to make sure to do is know how to use this one formula in those three circumstances, either looking for an accumulated amount, looking for the present value, or looking for the effective rate. Each one has its own slightly different setup. If you know how to set this same formula up in those three circumstances to find what it is you're looking for, you're good.